To my channel once again. This is Stoichiometry. In our previous lesson, we treated oxidation reduction reaction. In today's topic, we're talking about stoichiometry. Stoichiometry. The word stoichiometry is a very clear and concise word. Stoichiometry. 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 This word means measurement of element. Measurement of element. Measurement of elements in a given chemical equation. For us to know the amount of substances that reacted to give the product, we talk about this aspect of chemistry known as stoichiometry. So stoichiometry is the measurement of amount of elements that participated in a given chemical equation. That is, this amount is measured in moles, or in gram. We measure them in moles or in gram. So in this aspect of chemistry, it's very, very easy for us to make one or two mistakes when the balanced chemical equation is not well balanced. That is to say, for us to understand this concept, stoichiometry, we must know how to balance a given chemical equation. So with a given chemical equation, it gives us the information of the reactant and that of the product that is formed at the end of this reaction. So in this aspect, we are going to talk about how to balance this equation automatically. For us to balance chemical equation, we said when a given equation is written, we can balance the equation using 2 to infinity. So we can cite this inside this value into the equation for us to balance the molecules that are present in each of these aspects. So we said the one at the left hand side, we said is the reactant, while that at the product is the right hand side. That is, so let's use hypothetical equation A plus B to give C plus D. For this chemical, for us to know the amount of these substances, the first step is that we must balance this chemical equation. The chemical equation must be balanced. So in our first video, we treated how to balance chemical equation, and by so doing, if you are not good at balancing chemical equation, please do well to visit one of my videos on how to balance chemical equation. So let's come back to this topic. In this topic, we talk more about how these questions will appear in an examination. In stoichiometry, we have a problem known as mass problem. Mass problem. In mass problem, one of the problem you'll be asked, one of the mass of the substance will be given to you, and one of them you'll be asked to look for the other mass of that other compound. So by so doing, one of the mass is given in gram, you are asked to look for the other mass of the other substance. This is known as mass problem, because one of the mass is given, you are asked to look for this mass. So we also have mass moles relationship. Let's just use problem. So we are asked, one of the mass of these substances is given, you are asked to look for the moles of the substances that reacted or that is produced at the end of the reaction. We are going to talk about mass problem. Mass volume. So a mass of a substance will be given to us. We'll be asked to look for the volume that is produced at the end of the reaction. That is, in this, we're going to make sure that such systems satisfy what is known as STP. So we're going to look at this question so that for us to make reference to this subtopics we have arrived. We say one of them is mass problem. When the mass of a given substance is given to you, you are asked to look for the other mass of a given substance. By so doing, for us to look for the mass of the substance, we must know the molar mass of each of them. Then we compare the molar mass and what is given to us. We talk about the moles. So in this now, we must know the mass that is given to us. We can look for the moles by using a specific formula, very easy. We also have the mass volume. The mass volume talks about when the volume is at STP. We said when any gas is at STP is what? is 22.4 DMQ or 24,400 CMQ. So we're going to make use those analogy to explain this concept. So let's look at this question. From the explanation I've given, we said one of them say calculate the mass of solid product obtained when 16.8 gram of sodium hydrogen triazocarbonate 4 was heated strongly. So that is to say, a very strong solid is here. When it is heated, this solid will decompose into other products. That is to say, let's explain this. It says solution. So we are going to have here, we said when sodium hydrogen triazocarbonate breaks down, so I'm going to have a very simple equation. Here we are going to have, let's have our equation before dividing this board. We say we're going to have, when it decomposes, it's going to give sodium carbonate plus carbon 2 compound plus water. So as I've said before, stoichiometry must go with a well-balanced chemical equation. We said we have two sodium here. If we should have here, we have one sodium. Let's balance this chemical equation first. We say whatever that started the reaction will actually ends it. We're going to have sodium, hydrogen, carbon, and oxygen. Here, we're going to have sodium, hydrogen, carbon, and oxygen. So in this now we say we have one oxygen, one sodium here, one hydrogen, one carbon, 3 oxygen. Here we have 2 hydrogen is 2, carbon is 2, oxygen is we have 3 plus that is 6 oxygen. So you can see most of them like this is 1, this is 2, this is 1, this is 2, this is 1, this is 2. We have oxygen 3, we have oxygen 6. For us to have the stoichiometry of this reaction, this chemical equation must be balanced. How can we balance this equation? From our last video, we said we can add 1 to infinity to balance this chemical element. That is to say, if peradventure, let's add 2 here. For instance, yes, sodium times 1, I'm going to have 2 here. Here, I'm going to, how many hydrogen? 2 times 1, I'm going to have 2 hydrogen. Carbon is 1 here, 1 times 2, I'm going to have 2. Oxygen is 3, 3 times this, I'm going to have 6. So by so doing, let's check whether the chemical equation is balanced. We have sodium 2 here, hydrogen is 2 here, hydrogen is 2 here, carbon is 2, carbon is 2 here, oxygen is 6 here, oxygen is 6 here. With this chemical equation, we can say that this chemical equation is balanced. So having obtained this chemical equation, like a well-balanced chemical equation, we are going to make reference to the question again to know the compounds that are what? That are required in this calculation. Calculate the mass of solid product obtained. If you check here, I'm going to have gas here. Here, let's have gas here. The only solid here is this aspect. So for it to decompose, to undergo heating, this is solid. So we're going to, what is produced here, we have this that is mentioned and this that is mentioned as well. So the carbon dioxide and the water does not actually concern us in this calculation aspect. So we are going to, with the first step in calculating this kind of problem, if you can see now that we are asked to look for a mass, calculate the mass of solid product. We are asked to look for mass, and the mass of one of them is given to us. As I've said before, if a mass is given to us, we are asked to look for another mass. This is known as mass problem. So the first step in looking for the mass problem, we must have a balanced chemical equation. The other step, we must know the molar mass of each of these compound. We must know the molar mass of this compound, we said the relative atomic mass of all these compounds gives what is known as molar mass. The relative molecular mass of sodium, let's say sodium, the relative atomic mass of sodium is 23, hydrogen is 1, carbon is 12, oxygen is 16. So by so doing, if we are able to calculate the molar mass of this and the molar mass I mentioned in the question, we can compare each of these molar mass. We said here we have sodium. Let's solve for the molar mass of each of these compounds that is mentioned in the question. We said sodium occurred one time. The sum total relative atomic mass is the molar mass. So we are going to use addition, 23, plus hydrogen occurred only once, 1 times 1, plus carbon exists, had only, let's bracket this so that we will be very, very confused. We have carbon occurred once here times 12, plus oxygen occurred 3 times relative atomic mass of oxygen is 16. So by so doing, we said 23 here, plus 1 here, plus 12, plus 32, plus 16, are going to have 8, 4, 8, 4, 8. So by so doing, we said 4 plus 12, are going to have 10. You are going to have 60 plus 24. You are going to have 84 gram. We are going to write it somewhere. We said sodium hydrogen triazocarbonate. The molar mass is 84 gram. 84 gram of this. So we can look for the molar mass of the other compound that is mentioned in the question. So let's look for the molar mass of sodium carbonate. Sodium here occurred 2 times. 2 times 23. 23 plus carbon exists. Had only 1 times this 12 relative atomic mass of carbon. We say plus, we have oxygen occurred 3 times 16. So by so doing, we have 4 6 plus 12 plus 48. Say 48, 32, 16, 8, 48. So by so doing, 48 plus 46, we are going to have 14. Here is 9 plus 12. I'm going to have 6, 106. We said sodium carbonate is equals to 106 gram. So we cannot compare this reaction. We have obtained the molar mass of each of these compounds that are mentioned in the question. We can infer that for us to write a statement from this question, we can say that 2 moles of sodium hydrogen triazocarbonate produces 1 mole, because we have only 1 mole here, we have invisible 1 here, 1 mole of sodium carbonate. So since it's given in gram, we are going to have this, that since we have 90 sodium hydrogen triazocarbonate is 84, the molar mass of sodium hydrogen triazocarbonate is 84. We said times the mole, the number of moles of sodium hydrogen triazocarbonate produces the molar mass of this is, it has 1 mole, 1 times 106 gram of sodium carbonate. You can see this now. We have compared So invariably we have 8 6 8 4 plus 8 4 are going to have 8. This is 8 16 178. All right, so we have 178 here. Let's have, since we have compared the grams of both of them in the reaction, how much more if we should say this, let's say, yeah, 178 gram of this hydrogen produces this one times this is 106 gram of sodium carbonate from a balanced chemical equation. And from the equation, they said 16.8 gram of this was heated, not the full quantity of the molar mass of this sodium hydrochloride. So now we are going to have how much more is 16.8 gram of this sodium hydrogen triazocarbonate to give us. We don't know, it's going to give us S. They're going to give us S. By so doing, we can cross multiply so that for us to have the number, the gram of sodium triazocarbonate that is obtained from 16.8 gram of sodium hydrogen triazocarbonate 4. So by so doing, let's wipe this so that it will be clearer. So let's cross multiply this so that the equation will be linear. We're going to have, we said S here, that is this. We said S times 178 gram will give us, we give 106 gram times 16 point what? 0.8 gram. So we have made the equation linear. By so doing, for us to have S to be on its own, we divide both sides by 178 gram. Divide both sides by 178 gram. So by so doing, we can say we can have a more S times 178 divided by 178 to give 106 times 16.89 all over 178 gram. So this all, one of them will cancel this, so that this will cancel this, this will cancel this. We are left with S is equals to 106 times 16.89 all over 178. So by so doing, if we should multiply this, supposed to have a more, let me get a calculator. I'm going to have 106 times 16.89 divided by 178. Here we have S is equals to 10.06 gram of this compound is formed when 16.08 of sodium hydrogen triazocarbonate is what? Is heated. So this, with a very clear one, this is a very clear and concise way to solve mass problem. For the basic term is that a given chemical equation must be balanced. When the chemical equation is balanced, the next step, you must identify what you are asked to solve for. If one of the mass is given to you, the other mass is given to you, you must pick out these two compounds out, look for the molar mass of this, look for the molar mass of whatever that is mentioned to you. You compare the molar mass of each of them, multiply times the mole ratio of each of them. From there, you bring out the gram that is given to you, so that you can work it out. So whatever you are looking for should be at the right hand side. Since I'm looking for this product, every statement I will make, this this product must be at the right hand side so that I can compute my result and have the next stage in this calculation. So this will take us to the next question. Take us to the next question. If you should have any question, please do well to comment on the comment section so that we can have a replay of this. So let's check the question 2. We said calculate the number of moles of calcium chloride that can be obtained from 25 grams of limestone in the presence of excess acid. The presence of excess acid. Say calculate the number of moles. We're talking about moles here. Moles, and from what is given to us is in gram. So this now we can say this is mole to gram problem, or just say mole to mass to be general, mass problem, or mass to mass problem. So whatever case, they are the same. So for this now, our ability to write this chemical equation will give us a better understanding of what is happening during this reaction. So by so doing, let's have the chemical reaction of this question. We said limestone. So in excess acid, let's use ACl. We're going to have, when it decomposes, I'm going to have calcium chloride plus carbon dioxide plus water. So as I've said, this is a given chemical equation. If this is the product, So we must know whether this chemical equation is balanced or not. We say whatever that started a reaction here actually ends it. Law of mass action. We said A, calcium must be here, carbon is here, oxygen is here, hydrogen is here, chlorine is here. So same chemical element must be present at the product. Ca energy cannot neither be created nor destroyed in ordinary chemical process. So by so doing, whatever that started the reaction must actually end it. So we have calcium here. We have one calcium. Here we have one carbon. Oxygen is what? Is 3. Hydrogen is 1. Chlorine is 1. Yeah, let's check the product. Calcium here is 1. Carbon is 1. Oxygen is, we have 2 here, we have 3 here, we have 2 here and 1, that is 3. Hydrogen, we have only 2 here. Chlorine, we have 2. So let's check the equation. Calcium 1 here, calcium 1 here. Carbon is 1. Carbon is 1 here, carbon is 1. Oxygen is 3. Oxygen is 3 as well. Hydrogen is 1. Hydrogen is 2. Chlorine is 1 here. Chlorine is 2 here. So let's check this way. We have hydrogen and chlorine in this part. Since this calcium and carbon, they are correct. Oxygen is correct as well. We will not touch this aspect because most of these elements that is here, they are balanced. So the only one that is not balanced is hydrogen and chlorine. If peradventure, if I should add 2 here, so this 2, the hydrogen here, 2 times 1 here will now give me 2. 2 times chlorine will now give me 2. So if you check this equation, both sides are balanced. Calcium 1, carbon 1, both of them are balanced. So this is what we are trying to say about all this. We must have a balanced chemical equation for us to know the amount of these substances that came together to give the product. So what is mentioned here, calculate the number of moles of calcium. In this aspect, if you check here, what is mentioned, calcium chloride is mentioned to us. We say you should look for this mass of calcium chloride. We said can be obtained from 25 grams of limestone I'm going to talk about this aspect. So what can we do in this aspect is that this and this is given to us. We say here we 25 grams of this is given. So we're talking about calculate the number of moles of calcium chloride that can be obtained from 25 grams of limestone. So in our mole ratio, we are told that mole, the number of moles can be obtained using three formula. We say one of them, one. We say number of moles. When we discuss mole concept, number of moles equals to given gram all over molar mass of the substance. So by so doing, we say the other one is a number of moles. If we want to know the number of particles in a given equation, we said number of particles all over Avogadro's constant 6.02 times 10 raised to the power 23. We say we want to know the number of moles in solution. We say number of moles is equal to molarity times volume all over 1000. So this is the basic three equation used during mole concept. By so doing, we are going to make use of this first equation. Since the mass of a given sample is given to us and the molar mass, we can identify the molar mass or calculate for the molar mass. These moles will be very, very important for us. So from the statement of this, from the given stoichiometric reaction of this equation is that one mole of this carbon triazocarbonate produces 1 mole of calcium chloride during this chemical reaction. So for instance now, what is the molar mass of this? Molar mass of calcium triazocarbonate. So let's talk for the molar mass of calcium carbonate. We said the relative atomic mass of calcium is 40. Carbon is 12. Oxygen is 16 as well. By so doing, if we should have the calcium occurred how many times? 1 time 40 plus 12, 1 times 12 plus 3, it occurred 3 times 16. So if we should we have 40 here plus 12 plus what? 48. So 48 plus 12, we have 0, 60. 60 plus 40, we have 100 grams of calcium triazocarbonate. So the molar mass of calcium triazocarbonate is 100 grams per mole. So we can say, we can look for this number of moles of this reactant. They are reacted to give this calcium chloride first. Let's say we said number of moles. We can divide a number of moles is equal to given gram all over molar mass. We say the given gram that is given to us is given gram of calcium. This is the limestone is 25 grams divided by 100. What is the molar mass of calcium triazocarbonate? Is 100 grams per mole. So gram cancel gram. So here, going to have 25 divided by 100. I'm going to have 0.25 moles of what? Of calcium carbonate. Calcium triazocarbonate. So if paraventure, we have in this case that if 1 mole of this give this, we can equally say, let's wipe this so that we can make a very clear statement. We can have this as, then if 1 mole of calcium triazocarbonate produces 1 mole of calcium chloride, how much more is 0.25 moles of calcium chloride or calcium triazocarbonate will produce S? We don't know. We don't know. We don't know. So by so doing, if we should multiply, let's make it linear as we did it in the other question. We said S times 1 is equals to 1 times 0.25. So by so doing, 1 times this is the same as 1. So S, we're going to have 0.25 all over what? All over 1. So S is equals to 0.25 as well. 0.025 of calcium chloride is produced. So we can infer using this simple equation. So since they have 1 mole in a given laboratory work, if paraventure is very clear now, 0.25 is produced. So let's wipe this. Let's make a very clear statement. Because the reason we're having 0.25 on both ends is that since we have 1 mole here, 1 mole, if paraventure in a laboratory work, I'm asked to measure like a 10 centimeter cube of this calcium triazocarbonate. That should measure this. What I will measure here to be what? To be 20 centimeter cube, because the mole of this will tell me the amount of substances that are produced. Since there is 10 here, whatever that is produced that is 1 mole will be 10 centimeter as well. Here will be what? 10 centimeter. Here will be what? 10 centimeter. That is, whatever that is produced at the product is 30 centimeter. So whatever that reacted together must be what? Is giving us 30 centimeter. So this is a very simple illustration on how to go about this topic. So thank you for watching. This will be the end of this lesson. Please do well to comment on the areas that you do not understand. So in our next topic, we are going to take more of this example so that you'll be acquainted with different methods at which you can go about this calculation in chemistry. Thank you.